Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into a little mind map here on complex numbers, all right? And this is based upon our lesson in 8.2 here in Unit 8 in AP Pre-Calc here at Great Oak High School in Temecula, California. And what we need to understand here is that, and what I'm trying to impart, is that you need to learn how to study effectively, okay? And you need to learn how to take a concept that you learned in any lesson, all right, and really go into depth on it so you understand all different variations of the concept. In this lesson here, we talked about how to get from complex form to trig form, learning how to get the modulus and the polar angle and write it in trig form. And so what I did was I just came up with just four basic examples, all right, of complex numbers, one in each quadrant. That's why it's entitled, complex to trig form in all four quadrants. And we're going to go over how to get the modulus and the polar angle in all four quadrants. And that's really important because in the lesson, I didn't do that. Okay, I gave you one or two quadrants, but I didn't go over all four. You got to dive into your homework to get into that. But what you want to do is after you go through the lesson, after you go through the homework, is like synthesize it, put it all together, and create a mind map on your own representing the concept, but like in all the different variations. And so that's what I'm trying to teach you guys in this one here. All right, and I just made these complex numbers up. So let's go on into it here. If you haven't got these all set up, then just kind of take free notes. Just kind of develop this as you go. Pause and play as you like. And let's get into it. Okay, so here we go. Quadrant 1, z is equal to 4 plus 3i. And we want to go into trig form. So you have to know what that is. So let's start off that. Let's grab a red pen here and let's just take a look at trig form in general, right? So in trig form here, we take the modulus r times cosine theta, all right, plus I sine theta. There's trig form. And complex form, just general rectangular complex form, we have two names for it. We call it rectangular form. I'm off the page, the rectangular, shoot, rectangular, come on. There you go. All right, is A plus BI. Sometimes we refer to that as Cartesian form from René Descartes. Okay, so Cartesian form, rectangular form, A plus BI, you got it. Okay, so here our Cartesian or rectangular form is 4 plus 3i. And what we want to do is find the modulus and the polar angle to get that in trig form. So here we go. So what I'm going to do first is understand that here we got 4 for A, 3 for B here. We're talking about the real and imaginary components right there. And theta is some quadrant 1 angle right there. And R is the distance from the pole to the point, right? Everybody knows that. So when we take I call that R right there, but again, the modulus, keep saying the word modulus here. The modulus is equal to R, the radius. That's a special name or symbol, the absolute value of z, where z is your complex number here. So R and the modulus and the absolute value of z are all the same thing. Okay, it's just the distance from point to pole, as I talked about in my lessons. And the way you get that is by using your Pythagorean theorem. Okay, so we understand that 4 squared plus 3 squared is equal to r squared, or absolute value of z squared. All right, when we square both sides, we get r is equal to this. So it's the square root of 16 plus 9, that's 25. And the square root of 25 is 5. So we know the modulus is 5. So I can say, or the absolute value of z is 5. There's your modulus. Okay? That's the distance from the point to the pole. That's all it represents. Nothing fancy. Okay, now to get the polar angle, theta, we know that tangent theta is equal to b divided by a, or opposite divided by adjacent. So I'll just put b over a just in general here, but in this case it's 3/4. And then we also know that we have to take the inverse tangent of a ratio, 3/4, to get our polar angle. And that's where your T84 comes in. I don't have the T84 on my iPad, so I'm going to be using Desmos. But again, use whatever technology you have. Okay, and so let's take the inverse tangent of 3/4, so 3 divided by 4. All right, let's click on the wrench. If you're in radians, you got to be in radian mode here. I'm going to express all my answers in radians, so make sure you're in radian mode on your TD4, or in Desmos, just click on the wrench and change it to radian mode. I think the default is radian mode, but just make sure that you should always check by clicking on that wrench in the upper right. All right, and it's about 0.644 radians. So theta here is about 0.644 radians. I'm going to put RAD for radians right there. And that makes sense. Okay, that's quadrant 1. Okay, so now what we want to do is write it in trig form, right? And like I said before, right in the middle of the screen right there, that trig form z is equal to r times cosine theta plus I sine theta, right? Okay, so let's finish up. So what do we have? Our complex number, okay? 4 plus 3i is equivalent to your modulus, 5, okay? It's 5 units away from the pole, times cosine theta, which is 0.644, yeah, okay, plus I times the sine of your angle, 0.644 radians. There we go. And that is equivalent to A plus BI. Actually, I should have written the actual number here, 4 plus 3i. So 4 plus 3i. These are the same. Okay, they're equivalent. They're just in two different forms. Okay, so what we have in quadrant 1 is our first example here. We converted 4 plus 3i to its trig form, and where we found the modulus and the point angle. And all we want to do is get really good at that, right? So the way to get good at it is by exploring all the different quadrants. Right? You don't fully understand something until you explore it in all its variations. Okay, so that's what this mind map is all about. So on this next one here, we've got quadrant 2, and you got negative 3 plus 3i. Okay, and so that's obviously left 3, up 3. So left 3, up 3. And now look at this. The polar angle is in quadrant 2, so it's bigger than 90 and less than 180. So we're expecting that. Okay. Now this is an isosceles right triangle, so this is kind of nice. Hopefully you guys identified that. We talked about this. So whenever you see an isosceles right triangle, it's the famous 45, 45, 90. All right. So I know that this angle in here is pi fourths, and I know that theta is 3 pi fourths. Okay, just by inspection. But I'll go ahead and do the take a look at tangent inverse and all that kind of stuff, just to verify everything I'm saying. Okay, so what we want to do is get the modulus. Okay, r is the radius of the modulus, same thing. So let's do that. So r in general is the square root of a squared plus b squared. That's straight from the lesson. Okay, so we take negative 3 squared plus 3 squared. Notice I put negative 3 in parentheses. And I got the square root of 9 plus 9, or 18. Now the square root of 18, all right, is the square root of 9 times the square root of 2, which is 3 rad 2. So you should probably simplify your modulus there. Okay. Now I know just by looking at the triangle here what theta is, but here's what happens if you don't recognize it. Okay. You know that theta is the tangent inverse of b divided by a, which is 3 divided by negative 3. So theta is obviously the inverse tangent of negative 1. And you know that the inverse tangent of 1 is 45 degrees, or pi fourths. But in negative 1 here, tangent is restricted to either quadrants 1 or 4. So here, theta is equal to negative pi fourths. But as you can tell, that's not the correct angle. So if you just extend the modulus down into quadrant 4, watch what happens here. Okay, you'll notice if you graph negative pi fourths here, okay, you can see that if you did use a calculator here and you got negative pi fourths, which is obviously the decimal here, you have to get to quadrant 2 from that. Okay. Okay, so how do you do that? All right, so first of all, what's the easiest way to do that? This is quadrant 4. Well, just add pi. So this is quadrant 4, all right? And to get from quadrant 4 to quadrant 2, you add pi, so add pi here. So negative pi fourths plus pi, guess what? That's 3 pi fourths. There we go. And so your angle now, or excuse me, your complex number in trig form would be equivalent to your modulus 3 rad 2 times cosine of your angle, not negative pi fourths, but 3 pi fourths, because you want to express it as a positive angle, plus I times the sine of 3 pi fourths. And there we go. And again, that's equivalent to negative 3 plus 3i. This is equal to negative 3 plus 3i in rectangular form. Okay, so we have trig form, rectangular form, there's polar form too. As you guys know from the lesson here, there's 3 forms for every complex number. And what we're trying to do in this little mind map here is to get good at all 4 possibilities or 4 variations, because obviously there are 4 quadrants, right? So you got to get good at converting from rectangular to trig form in any quadrant, because you don't know what's going to be on the test, right? So you got to study in such a way that you're going to be able to handle anything, right? So obviously you got to handle all 4 quadrants. Now let's take a look at quadrant 3. All right, so let's graph it here. So we're going to go left 3 down 4. So left 3 down 4. Here's your modulus. And I'll tell you what, theta is between 180 and 270. It's a big angle, right? It's a quadrant 3 angle. All right, so here we go. Let's get the modulus first. Actually, it's a 3, 4, 5 triangle. So you know what? Let's save time. We already did that in problem number 1 in quadrant 1. We know it's a 3, 4, 5 triple. So we know the modulus. Because it's a 3, 4, 5 triple here, the modulus is 5. Okay, so we know that. So the only thing we need to do is figure out the polar angle. And it's got to be a quadrant 3 angle, because obviously the point's in quadrant 3. Okay, so now if we take the inverse tangent of b divided by a, which in this case is the inverse tangent of negative 4 thirds, excuse me, negative 4 divided by negative 3, notice that we get the inverse tangent of 4 thirds. And it's positive because the negatives cancel, right? So here we go. Let's bring in the decimals here. All right. And let's take the inverse tangent of 4 divided by negative, or 4 divided by 3. So 4 divided by 3. Okay, it's in radian modes. Okay, and this is equal to 0.927. So 0.927 radians. So make sure you put radians there, just so you know. Well, guess what? That right there, if you just extend the radius into quadrant 1 by going right 3 up 4, okay, that angle right there, 0.927 radians, is quadrant 1. Well, we don't want quadrant 1. We want a quadrant 3 angle, right? So what do you do to quadrant 1 to quadrant 3? Or to get to quadrant 3? Well, guess what? You add a pi. All right, you add pi radians. So what we want to do, and this is you always do this, by the way, to get from quadrant 1 to quadrant 3, you always add pi radians. So really our angle, okay, so I'm just going to put in a plus pi here, is 4.069, I guess. So 4.069 radians, and that is quadrant 3. And that's what we want. Okay, so now we can write our trig form. Here we go. So z is equal to our modulus 5 times cosine theta, which is 4.069, plus I times the sine of 4.069 radians. And there we go. That is trig form. So notice that when we work with these here, the methods of getting our angles is slightly different. If you're in quadrant 1, it's easy. You know, when you take the inverse tangent, that's what it gives you. In quadrant 2, okay, you had to add pi. Okay, in quadrant, or excuse me, yeah, you had to add pi, and you get quadrant 2. And then in quadrant 3, to get from quadrant 1 to 3, you have to add pi again. Now quadrant 4, guess what? It's slightly different. All right, so let's give this a shot. So here on this one here, we will write 2 down 4. So write 2 down 4. Okay, there's the radius here, and the the polar angle is big. It's between 270 and 360, right? Because we're talking about quarter 4 angle. So let's get the modulus first. Here we go. So r is equal to the square root of a squared plus b squared. As always, that's our basic definition of the modulus. And here we get negative 2 squared plus negative 4 squared. Notice how I put parentheses around the negative 4. Whenever you square a negative number, give it a hug. Put parentheses around there. Okay, otherwise you're not going to get the right result. Okay, and so you get 4 plus 16 over root 20. Okay, and the square root of 20 is the square root of 4 times the square root of 5. And, well, you guessed it, the modulus is 2 rad 5. Okay, so now you get your polar angle here. So theta is equal to the inverse tangent of b divided by a. So it's negative 4 divided by 2. Simplify a little bit. So inverse tangent of negative 2. Kick in the calculator when you need it, and we need it. Okay, so here we take the inverse tangent of negative 2. Ooh, I mean to do that right there. Okay, so okay, there we go. Gotta make sure I'm on the right portion of Desmos here. So inverse tangent of negative 2. And notice it gives me an angle in quadrant 4. That's negative. Okay, so here we've got negative 1.107. Negative 1.107 radians. This is quadrant 4. Okay, now we don't want that, right? So negative 1.1. Let me just slide that over there. Okay, so this angle is, notice it's negative 1.1, negative 1.1. Everybody knows this is a clockwise rotation, and that's quadrant 4. We don't want that. We want theta as a positive angle between 0 and 2 pi. So what do? We take this, and we add 2 pi to it. So add 2 pi radians, and guess what? We get 5.176 radians. So plus 2 pi. And this will jump us into quadrant 4. This is a coterminal angle here, 5.17 radians. Okay, it's coterminal with a negative 1.107 radians. Coterminal, and thank God you guys know coterminal angles. All right, so this should make sense because we've been building concepts, right? And this is the reason why we talked about coterminals, because we need it. So now our final answer here in trig form is 2 rad 5 times cosine of theta, which is 5.17 radians, plus I sine 5.17 radians. Okay, and that is your trig form. So notice what we did here. If you take a look at all 4 cases here, all right, we learned how we go from Cartesian or rectangular form to trig form, but with all 4 quadrants. And this is how you guys should study, right? Doing one example and getting good at only one quadrant is not enough to do on the exam because you have no idea what quadrant you're going to be given. So you have to study all variations. And how do you do it? Well, you get creative and you learn how to mind map a concept and take a look at all the different possibilities related to that concept. Okay, and so the key in school, in my opinion, is learning how to study effectively. And so that's one of the things, in addition to the mathematics that I'm trying to teach you guys, is learn how to study effectively, right? And by making mind maps. This is one of many ways, but this is a very effective way. All right, so give it a shot, and I would repeat this mind map until you can do it easily, until you can do it perfectly. And it might take 2, 3, 4 times, but I'm telling you, the practice will be worth it, and you'll be proud that you did. So I'll see you in my next video and hopefully in class. Take care. This is Mr. Aynesworth. Bye-bye now.